This class, this class is for computer programming using Pascal and assembly language. I'm already sharing my screen, and from there, I believe you can actually see the material which I'm using. This course is divided into two sections, which is the Pascal and assembly language. The Pascal and assembly language. We understand that for us to communicate with systems, for us to actually interact with them, there are things which we have to take note. We have to take note of. So these things which we have to take note are actually called programs. The programs. So we're going to start with the introduction first. From what is being displayed on my screen here, computer programming language are any of the various languages for expressing a set of detailed instruction for a computer. For you to actually solve a problem with a computer, like yesterday, which we talked about your algorithm, there are ways which we communicate with the system. It's just like me, you coming to me and you are speaking English to me. Because I understand English, I would be able to reciprocate to you. But in a situation whereby you come to me and you are speaking a different language, let's take for instance, Mandarin. I don't understand Mandarin. There will be some obstruction. There will be no feedback, because in the real sense, there is something that is obstructing the flow of information. So in the same way with computer systems, so for you to interact with your systems, for you to give it instruction, the computer have its own language. So if you are able to communicate with the system in the language which it understands, thereby it will give you your desired output. That is for that. So such instruction can be executed directly when they are in the computer manufactured specific numerical form known as machine language. So understand that the native language, or the native, permit me to use the word native dialect of the computer, is what is called machine language. Machine language. Before the end of this class, you should be able to determine three things by the end of this class. The three things is: number one, what is the native language of the system? Then secondly, what are other languages which the computer can be used to communicate with? Because the truth is that you can actually start writing programs in the machine native language, because it is what is called ones and zeros, your binary numbers. That is what is called your machine language. Then the third thing which you should be able to establish by the end of this class is for you to know that there are various types of languages apart from your machine language and your assembly language. There are other types of languages. So take note of this. The instruction, whichever language which you are writing, whichever language which you are using to communicate with the system, at the end of the day, there is something called compiler or interpreter. Depending on the programming language which you are using, it transforms it to the native computer language, which is binary numbers, which is made up of ones and zero. That is what the system understands. So from there, it is being, whatever thing you have imputed, Whatever thing which you have imputed at the end of the day, once it is being transformed, once it is being interpreted, then the system will be able to execute it. Okay. So after a simple substitution process, when expressed in a corresponding assembly language, or after translation from the high-level language. So in essence, what this place is telling you that whichever language which you have written it, be it assembly language or high-level programming language, at the end of the day, it is being transformed to your binary numbers, to the computer native language. Although there are many computer languages, relatively few are widely used. Then we should understand that the computer language is divided into three, which are machine language. As I said earlier on, machine language is the first one. Then the second one there is low-level programming language. Then the third one there is high-level programming language. There are three languages. The three languages for this computer systems. The first one is machine language, the second one is low-level programming language, and the third one is high-level programming language. Okay. So, example. What are the examples of low-level programming language? Example of low-level programming language is the assembly language and machine language. That is the example of low-level programming language. Low-level programming language are assembly language and machine language. Okay, let's have a definition of what machine languages are. Machine languages sometimes are referred to as machine code or object code. They are referred to as machine code or object code. Machine language is a collection of binary digits or bits that the computer reads and interprets. These are actually made up of ones and zeros. Machine language is referred to as machine code or object code, a collection of binary digits or bits that the computer reads and interprets. That is the definition of machine language. Why is it so? The reason is that a computer or a system cannot directly understand the programming language. It cannot directly understand the programming language used to create programs. So the program code must be compiled. It must be compiled. Compilation here means transforming it into the machine language. Take, for instance, you are programming. This course is made up of Pascal and assembly language. Understand that your Pascal is a high-level programming language. So after computing, putting in sets of instruction on your Pascal language, what happens behind the scene is that these sets of instruction which you have imputed is being transformed into ones and zero. Everything is being interpreted one after the other so that your computer will understand what you have imputed, what it's supposed to do. Okay. Then what is assembly language? What is assembly language? An assembly language is a low-level programming language Just like we said earlier on, when we were giving examples of low-level programming language, we made mention of that we have two examples of low-level programming language. The first one is your machine language, and the second one is your assembly language. An assembly language is a low-level programming language for microprocessors and other programmable devices. It is not just a single language, but rather a group of languages. An assembly language implements a symbolic representation of the machine code needed to program a given CPU architecture. Assembly language, take note of it. Number one, first thing you should take note of assembly language is that, number one, it is a low-level programming language. Then secondly, it is a language that is used for microprocessors. Your systems are made up of processors and microprocessors. That is the second thing you have to take note of it. Then the third thing is that it is not just a single language, but rather a group of languages. That is the three things which, for now, you have to take note for an assembly language. Then, talking about your assembly language, there are things which you have to take note of when you are talking about assembly language. There are things which you have to take note of. The first thing there is what is called ALU, A-L-U, ALU, A-L-U. ALU, the full meaning of ALU is arithmetic logic unit. Arithmetic logic unit. What is arithmetic logic unit? Arithmetic logic unit is a digital circuit used to perform arithmetic and logic operation. It represents fundamental building blocks of the central processing unit of a computer. In talking about your assembly language, there are things which we have to note. The first thing there is your ALU, and the second thing there is your registrar. ALU is where the computation is being carried out, be it logical or arithmetic. Okay. For the sake of more explanation, I'm going to minimize my screen now and show you a typical example of what assembly language looks like. Please take note of these things which I just ticked now. Please take note of it. This is a typical representation of what assembly language looks like. This is what it looks like. From the definition of what ALU is arithmetic logic unit. It's a digital circuit used to perform arithmetic and logic operation. It represents the fundamental building block of the central processing unit, which is the CPU. So on this first block, we have your PC. Then the first block, you have this thing which is written there. From this end, you have add R1 and R2. Subtract R2 from R3. Compile R3, R4. This is a representation. This is how assembly language is being written. This is how assembly language is being written. So from here, the computation is being done in your ALU. ALU. Your ALU is where the computation is being done, be it logical or arithmetic, whatever it is. That is where it is being done. Then after the computation, be it arithmetic or logic, after it is being carried out, then it is being stored in your register. It is being stored in your register. Now, let me go back to our material. Now, your register is a quickly accessible location available to a computer central processing unit. So after the computation, the transformation is being carried out in your ALU, then it is being stored in your register. In your register, that is where the result is being stored. A register is a quickly accessible location available to a computer's central processing unit. Register usually consists of a small amount of fast storage. Register usually consists of a small amount and fast storage. The reason for it to be small is that the sizes of this computation are really very, very small. Most of the times you could see as much as 1,000 or a million lines of code written in assembly language, and you still see it in a very minute size, talk of less than even kilobytes. Less than even kilobytes. So the essence for it is that you discover that the smaller a storage system is, the faster it is for it to be accessible. The faster it will be for it to be accessible. So that is the reason for that. So take note of this. Talking about assembly language, you need to talk about the ALU, where the information, where the logic is being carried out, the logic or the arithmetic transformation is being carried out, then whatever thing it is, after the end of the transformation, then it is being stored in the registrar. So assembly language are one step up from machine language. In the hierarchy of languages, programming languages, in the hierarchy of computer programming languages, at the top you have high-level programming language, your high-level programming language. Then in the middle you have your assembly language. Then beneath it, which is the last, you have machine languages. So understand that in whatever, be it your high-level programming language, which is your Pascal or your assembly languages, whichever of these two which you write your program, at the end of the day, it is going to be compiled. It is going to be interpreted in your machine language. So that is why it is being said there that your assembly language are one step up from your machine language. They are one step up from your machine language. Originally, before the advent of high-level programming languages, assembly languages are considered to be user-friendly. They are considered to be user-friendly and a way to program compilers target model of computation. So before the advent of your high-level programming language, what was invoked was assembly languages. And that was what programmers were using. That was what programmers were using to get hold to get hold of solving problems. Okay. For that, from there, we move to another different thing entirely. Assembly language instruction are built for two specific reasons. They are built for two specific reasons, which are OP codes and operands. They are built for two reasons. Assembly languages instruction are built for two reasons. OP codes. The OP code here stands for operation codes. Then operand means from where this information are being gotten from where this operation are being gotten from. OP code means what to do with data. And the operand means where to get the data. OP code means operation code. What do I do with this data? Then operand means from where should I get this data, where this operation will be carried out on. What are the types of operation codes? There are so many of them here. We have the arithmetic, we have the logical, we have the addition, subtraction, multiplication, and of, compile, memory load, your storage, many of them. Jump, complex, move. These are all types of OP codes. These are all types of OP codes. So then, for your operands, each operand are taken from a particular addressing mode. Each operand, remember that we explained operands to be where to get information from or where to get data from. So this, for your operands, we have register, resource 1, R1 and R2. Immediate, add, resource 1, resource 2, and 10. These are where, that is what this place is actually telling you, is that you are actually telling the system, go to so register, add resource 1, resource 2, and resource 3. Then immediately add resource 1, resource 2. This is actually what you're actually telling the system to do. You are moving resource 1 to resource 2. Then we go to types of assembly language. We go to types of assembly languages. Types of assembly languages. Assembly languages are divided into 4. Assembly languages, they are divided into 4, called complex instruction sets computer, which is known as CISC. Complex instruction set computer, CISC. Then computer, known as RISC. The third one is digital signal processor. Then the very last one is very long instruction words. We'll be taking a brief look at each one of these types of assembly languages. The first one is computer. A complex set computer is a computation can be executed low level operation, a load from the memory and a memory storage. A complex instruction set computer is a computer in which a single instruction can be executed in several low-level operations. Take note of when we were defining assembly languages. We said that assembly languages are used in microprocessors, microprocessors and processors. And your systems are made up of microprocessors and processors. Please, we should take note of that. So for your complex instruction set computer, things that are being carried out in your complex instruction set computer are load from the memory, an arithmetic operation, and memory storage. And these are all done in all these are executed in low-level operations. Low-level operations. And take note, and these are also capable of multi-step operation or addressing modes within a single instruction. Your complex instruction set computer is responsible for load from memory. Load from memory means in a situation whereby after carrying out a computation and a situation calls for where this information, this data is being needed. Complex instruction set computer is responsible. That microprocessor is responsible to call out this load from the memory. It is responsible for that. Then the second thing there is another type of assembly language which is called a reduced instruction set computer, or RISC. It's a computer instruction set that allows a computer's microprocessor to have a fewer cycles per instruction than a complex instruction set. Take, for instance, comparing these two assembly languages now. One computes his computation in a more complex instruction, in a more complex way. And all these are being carried out, either are being carried out in a multi-step operation. That is for your complex instruction computer. But for your reduced instruction set computer, the microprocessors are being carried, the instructions on this microprocessor are being carried out in fewer cycles. That means it is not as complex as the first one, which is your complex instruction set computer. So per time, a single instruction is being issued. Per time, a single instruction is being issued. Please, we should take note of the similarities, the differences between these two. Although both of them perform the same work, but understand that the process of how they carry it out are different. One carries it out in a more complex way, and the other one carries its instruction out in a more simpler way or in a more reduced way. Then the third type of assembly language here is your digital signal processor. your digital signal processor. A digital signal processor is a specialized microscope chip. It's a specialized microprocessor chip with its architecture optimized for the operational needs of digital signal processing. Understand that this digital signal digital signal processor are what you can actually find most of the times you find them in your antennas which are used for audio signals. This is actually what you find in here. These are the type of assembly language microprocessors which you find here. You can find them in your area audio antennas, your speech processing devices, for your voice recognition, and most importantly, for your facial signals. These are where your digital signal processor are being used. These are the where they come into play. Due to my time, I'm actually trying to rush the whole thing so that we'll be able to meet up with that, what is here. Then the very last one is the last one, which is your very long instruction word. Very long instruction word. Your very long instruction word describes a computer processing architecture in which language compilers or preprocessor breaks program instruction into basic operation that can be performed by a processor in a parallel state. In a parallel state, your very long instruction word are found in your processing architecture. In your processing architecture, most type of your processing architecture is, take for instance your word processors and the rest of them. Most of them, they come with all special kind of devices. So these are where you can get hold of these types of assembly languages. These are where they are being used. So before the class come to an end, I would like us to ask any question. If there is something you are not actually clear with, you can actually call my attention to it so that I will give more explanation to that before we go to the assignment.
Okay. Good morning, sir.
Good morning.
Yeah, my name is Gospel.
Okay.
Yeah, concerning the lecture,
Okay.
it's very well, but I have two questions concerning the
It is
OP
very.
code and
It is very what? It is very
the
what?
OP code.
You
No,
said the
I
lecture
said
is very
I
what?
went along with. It's
Okay.
okay, it's
Okay.
okay. But I just have
Okay.
two questions
Okay. Okay.
concerning the OP code and the operand.
Okay.
Yeah.
Okay. Your question, please.
Yeah, the OP code and the operand.
Yes. Yes. Your question. The question. What is the question? Oh, you want
Okay,
more
I
answer?
didn't
You
really
want
get
more? You
that
want?
aspect.
Okay. You didn't actually get it.
Yes, I didn't
Hello.
get that aspect.
Okay. 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 Just are you seeing my screen?
Yes, I can see your screen.
Okay. Just permit me. I'm going to minimize now and bring up a new. Okay. Are you seeing the screen which I'm
Yes, I can
projecting
see
now?
it. Yes,
Okay.
sir.
Okay, look at from this place.
You
Are you
said?
seeing what I just marked? Did you see what I just marked now? Did you see what I just
Yes,
marked
I
now?
can see it. Yes,
Okay.
yes.
We
Okay,
have your assembly languages. Your assembly language. First of all, understand that your assembly languages is divided into two. Your assembly language model
okay.
are divided into two.
Yeah,
Are you with me?
yes.
Which is your OP code and your operand.
Okay,
Firstly, what does your OP code do? Your OP code is actually telling the system. Your OP code is telling the system of what to do with an information, what to do with a data. Are you with me?
yes, I'm with you.
Hello? Are you with me? Your OP code is actually telling your system
Yeah, I'm with
what to do with a data. Then what are the things that can be done with a data? The first thing here is it could be arithmetic or logic.
you. Okay,
Arithmetic transformation or your logic transformation.
yes.
That is, this is where you find your add, your subtraction, your multiplication, and the rest of them.
Okay, okay, okay.
Then for your operands, you see what I just marked now. You see what I just marked.
Yes.
Hello?
Yeah, I can see it.
Now, what are your operands? Your operand is telling the system where to fetch this the instruction is telling the system where to fetch this data.
Okay,
Then the instruction which you are giving to the system are to fetch this information from. Understand that in your
okay,
system you have different kind of storage. Understand that in your system you have different kind of storages. So, and the peculiarity of each one is attached to a
yeah, okay.
kind of a function. Are you with me?
Yes, sir.
So each of these operations, each of the functionalities which are to be carried out, they have their own peculiarity, they have their own special kind of storages. So the operations which are to be carried out determines where this information resides. And the instruction, an explicit instruction are to be given on where to take the information from. So that are the two types of assembly language models.
Okay. Thank you, sir.
Are you clear?
Yes, sir. Clear, sir.
Okay. Before we call it a day, because our time is almost up. I have some few questions here, which some assignments here which we have to take. Okay. In the absence of any questions, let's take down this assignment. The first one here is the first assignment. What are the following? What are the following used? What are the following used for? What are the following used for? What are they used for? Complex. First one there is complex instruction set. Instruction set computer. What are the following text instructions set computer? And very long instruction word to their purpose and function, according to their purpose and function. 3. Question. Segregate the following into their purpose and function. Accumulator register, open bracket, AX, close the bracket. Segregate the following into purpose and function. The first one is accumulator register, AX. We have data register, DX, base register, BX, register, CX, instruction register, IR, memory address register, MAR, memory buffer register, MBR, program counter, PC. I go over it again. Segregate the following into their purpose and function. Accumulator register, AX, data register, DX, base register, BX, counter register, CX, instruction register, IR, memory address register, MAR, memory buffer register, MBR, program counter, PC. This assignment is to be submitted before our next class, And the email which it's to be submitted is sharonchris29@gmail.com. sharonchris29@gmail.com. Please, if there is something which you are not clear with during the course of this, please do well to get across to me. You can actually text me, call me, text me, or WhatsApp me on this number, 081 3121 309, 081 3121 309. Please get across to me. You can either call me, text me, or WhatsApp me. I'll be glad to help you. Thank you very much for your time, and please try as much as possible to stay safe. Thank you very much. Have a lovely day.